Hello everyone, my name is Trisha Macy Hataina and welcome to Modern Physics in Action. Today, we're exploring the fascinating photoelectric effect. This concept was key to understanding quantum mechanics and even earned Albert Einstein a Nobel Prize in Physics. So what is photoelectric effect? It's the phenomenon where electrons are ejected from a metal surface when light shines on it. But here's the interesting part. This doesn't happen with just any light. The light must have enough energy, which depends on its frequency. Einstein famously explained this using quantum theory, proposing that light isn't just a wave. It's made of particles called photons. The energy of a photon is given by this equation. E is equals to h times f, where E is the photon energy, h is the Planck's constant, which has the value of 6.63 times 10 raised to negative 34 joules second, or 4.1357 times 10 raised to negative 15 electron volts second. And F is the frequency of the light. Take note, if the energy of light is greater than the metal's work function, or the minimum energy needed to eject electrons, electrons will be released. Therefore, photoelectric effect happens. Let's try solving a world problem using the knowledge we have with photoelectric effect. You're on a mission to explore an alien planet where the surface is covered in a strange shiny metal called tritanium. Scientists back on Earth have determined that the work function of tritanium is 4.5 electron volts. To investigate further, your spaceship emits light beams of varying frequencies, and one of them has a frequency of 1.1 times 10 raised to 15 Hz. Calculate the energy of light photon in electron volts and determine if the photon has enough energy to eject electrons from the surface of tritanium. First, let's calculate the energy of the light photon. In the problem, we have the following given. Work function is equals to 4.5 electron volts, frequency which is equals to 1.1 times 10 raised to 15 Hz, and we have the value of Planck's constant, which is 4.1357 times 10 raised to negative 15 electron volts second. Using the formula E is equals to h times f, or energy of light photon is equals to Planck's constant times frequency, we will now substitute the given values. So we will have energy of light photon is equals to the quantity 4.1357 times 10 raised to negative 15 electron volts second times the quantity 1.1 times 10 raised to 15 Hz. Using a scientific calculator, we will have the value 4.549 electron volts, or rounding it off to 2 decimal places, we will have 4.55 electron volts. So, the energy of the photon is 4.55 electron volts. Now, let's determine if the photon has enough energy to eject electrons from the surface of tritanium. The work function of tritanium is 4.5 electron volts, while the energy of the photon is 4.55 electron volts. This means the photon has enough energy to knock an electron out of the metal, since the photon has an energy of 4.55 electron volts, which exceeds the work function by 0.05 electron volts. The photoelectric effect revolutionized our understanding of light and matter. From solar panels to electron microscope, this phenomenon powers so much of modern technology. Thank you for watching this video and join me next time for more physics adventures.